Hi guys, this is Mrs. Chang. We're going to talk about solving compound inequalities today. I'm sorry that I'm going to miss you. But please get this note sheet from the sub. So you should have this note sheet in front of you, okay? And then you're going to watch this video and you're going to fill in the notes for the first and second pages with me during the video, and then the last 2 pages are going to be your homework, classwork/homework due next class, all right? All right, let's get started. So, compound inequalities. Here's a quick warm-up. Take a minute, look at this problem. So basically, if you're at the football game and your mom says, bring me a hot dog or a hamburger or both, your mom is happy if you come back just with a hot dog. She would be happy if you came back just with a hamburger, and she would be happy if you came back with both. The word or means one or the other or both. If your dad then says, here in number 2, bring me a hot dog and a hamburger, and you just bring him a hot dog, he's not happy. He wanted both. If you just bring him a hamburger, he's not happy. He wanted both. But if you bring him both, that's what he wanted. So keep these little examples in mind as we go through. Those 2 words, and or, are going to be your key words for today. So in your notes, we're going to talk about compound inequalities, like I said. The first type of compound inequalities that we're going to talk about are joined with the word and means intersection. So if you look at this Venn diagram here, the intersection of A and B is the part that's shaded in blue, okay? So if I want a hot dog and a hamburger, I want both. In other words, the intersection, what they have, or in other words, what they have in common, what the 2 items have in common. On the other hand, the word or means you want one or the other or both. So I would be happy with just a hot dog. That would be that section that I just colored. I would be happy with just a hamburger. That's that section. Or I would be happy with both. So basically, or means union. If it's in one item, it's in the solution. So it's a little quick overview between and or. Now, what does that look like when we're talking about, algebra? So you're going to see compound inequalities that look like this. So compound inequality are 2 different inequalities that are separated with either the word and or. So we're going to start with an and example. If you have x is less than 4 and x is less than or equal to 2, you want numbers that make both of those true. Remember we said and has to be both? So in order to graph that, you could just graph x is less than 4. So, let's see. So here's x is less than 4, starts here with an open circle, less than 4 goes down here. And then you can graph x is greater than or equal to 2. That would be a closed circle, because remember I would include that 2 in my solution. And then I'm going to combine the graphs. So here was that part, and here was the 4. If I started at the 4, and I would shade that way. And then we're asking, where do they intersect? What do they have in common? So the part that they have in common would be this 2, because they're both shaded here. The red part shaded and the green. It would be this part in the middle, but it would not be this 4 here, because the green part's shaded, but the red is an open circle, so it's not shaded. So where do they intersect? My final solution, they would intersect starting at 2 and including 2 and going everything up until 4. So think about it. This is your final answer, your final graph. When we went back to the original problem, graph x is less than 4 and x is greater than or equal to 2, we want numbers that are less than 4 and greater than or equal to 2. Well, what kind of numbers are they? 3, 3.5, 2.5, 2.1, the number 2 itself. So there's your solution there. On the other hand, if we look at an or example, so if you looked at one like this, if you wanted to graph x is less than 1 or x is greater than or equal to 3, you would start with x is less than -1. So open circle, and I would shade down there. And then x is greater than or equal to 3 would be a closed circle up here. And then I combine the two graphs, which would look like this. And then the question is, I want where one or the other or both are true. So where one or the other are true is basically this whole thing. This right down here would be your solution. And you can ignore part D here. We're not looking for where they intersect. We're looking for where either one or the other or both are true. So that part C, that would be your graph, okay? All right, let's jump down and let's do a couple more example problems. So most of the time, the inequalities are not going to be solved for you. So you're going to have to solve the inequalities first and then graph them. So real fast, number one, to solve this for x, I divide both sides by 2. And then separately, you're going to solve this other inequality for x. So here I divide both sides by 3, and I get x is greater or equal to 4. And then don't forget the word and goes in the middle. So if I ask you to solve algebraically, that's your solution. And then when I ask you to graph, again, I would start at -3, and I would say x is less than -3, right? And then I would start at 4, and I would say x is greater than or equal to 4. And I'm looking for where both this and this are true. I'm looking for the overlap. Does that happen at all? So they never overlap. The two of those things never happen at the same time. So therefore, I'm going to say that there's no solution. All right? So that's number one. Let's take a look at number 2. So first I would try and solve, but both of these inequalities are already solved for me. So now I can just go ahead and graph it. So I would look at 2, and I would say x is less than 2, and 4, x is greater than or equal to 4 would go like that. And I want where one or the other or both are true. So that would be my final answer. All right, a couple more practice problems. So again, go through and solve each of these inequalities. So I'm going to add 2 to both sides. I'm going to divide both sides by 4. I get x is greater than -5. Here I'm going to subtract 6. And then I'm going to divide both sides by 3. So, sorry about that. I'm going to divide both sides by 3, so I'm going to get x is less than or equal to 4. Don't forget the word and in the middle, right? So there's my solution algebraically. So this, when I graph each inequality separately and then I look for the overlap, there's where they would overlap. That's my graph and my algebraic solution for number 3. Okay, number 4. I would add 3 to both sides. Divide both sides by 5. Here I'd add 3. And then I divide both sides by 2. Again, don't forget the word or in the middle, okay? And then I'm going to graph this. I'm going to start here at 1. Y is less than. Y is greater than or equal to 3. So that's what that solution would look like. Again, algebraically and then the graph. All right, so sometimes you might see a compound inequality that looks a little bit different. In this case, you'll see I don't have the word and or in there at all. Whenever I don't have the word written in there at all, you can always assume it's an and type of an inequality. All right, so there's 2 different ways that you can go about solving this. One way would be to split this up. So basically, I can think of each of these inequalities as dividing the inequality symbols as dividing the inequality into parts. So I have 1 part, 2 parts, 3 parts, the left, the middle, and the side, okay? So one way that you can solve this is by splitting up, like basically the left and the middle, and making a compound, or making an inequality out of those. And then I could take the middle and the right. Notice I used the whole middle section again, right? 2n minus 1. And then, like we said, these are and inequalities, so I would write the word and in the middle. Then what I could do is I could just like we did before, I would solve each of these inequalities separately, and then put the word and in the middle. There's my algebraic solution, right? If I were to graph this, here's 2, 3, 4, 5, right? It would look like that, okay? So that's one way to solve this. Another way to solve it, and you can choose whichever one you would like, another way to solve it would be, again, to divide at the two inequality symbols. And just like with an equation or an inequality, whatever you do to one side, you do to the other. Now, whatever you do to one side, you do to all three. So I would start by adding 1 in the middle, but then I got to add 1 to all three sides. So this would be a 4 is less than 2m minus 1 is less than 9 plus 1 is 10. Oh, I'm sorry, the 1's cancel. I'm trying to go too fast. So this would be 4 is less than 2m, these cancel, is less than 10, right? And then to get the m by itself, I would divide everything, again, all three sides by 2, because I want to get rid of this 2. I want that to cancel. So 4 divided by 2 is 2, is less than n, is less than 5. So this means the same thing as the inequality that we just looked at. And then when I graph this, again, this says 2 is less than m. So here's 2. M is more than that. 2 is less than, right? So 3, 4, 5. Here's 5. And n is less than 5. So the graph would look this same. You can choose whichever method you would like to for solving these inequalities, all right? So let's look at 2 more example problems. All right, last 2 example problems. I'll use one method with number 5, and then I'll use a different method with number 6. So number 5, let me break this up into 2 compound inequalities, all right? So, or 2 inequalities. So I have 11 is less than the whole thing in the middle, right? And then I write the word and then I write the whole thing in the middle again is less than 20, all right? And then I would solve this. Don't forget, here at this point, I'm dividing everything by -3 because I'm dividing by negative. I got to flip that inequality symbol. Remember that? Again, when I divide by -3, we got to flip that inequality symbol. Write the word and in the middle. So I have -6, I have -3, right? And this says -3 is greater than y. So y would be down here. And this says y is greater than -6. So that would be my graph. That's number 5. Okay? Let's look at number 6 now. Let me erase this. I'm going to look at number 6. And instead of dividing it up into 2 inequalities, I'm going to think of this as having 3 different sides like we did before. So to get the c by itself in the middle, I have to subtract 1 first. And that would cancel out, but I got to subtract 1 from each part. So this would be -25 over here. And then to get the c by itself, I would divide by -5. Again, all 3 parts I'm dividing by -5. So I have -7. When I divide by a negative number, I have to flip the inequality, and then c, and then flip the inequality, and then +5, okay? So that is my solution algebraically. And then when I graph, I have -7, I have 5, that would be my solution. All right, thanks for watching. Go back and rewatch any part of this video if you missed it or if I went too fast. And then you guys have to finish the mixed review practice problem in class and for homework. Thanks so much.